All right, our objective for the day, I can multiply and divide with decimals. Now, the thing is, the truth is, if you can multiply and divide with just regular old-fashioned numbers, then this should go pretty well, relatively at least. Of course, we're going to add a couple extra rules or steps to the process, but if you can do it with regular numbers, you can do it with decimals. Just you need some practice in order to get the rules down. Okay, multiplying decimals with the grid. So you shade one factor vertically, and then you shade the second factor horizontally. If we've forgotten what factors are numbers that are multiplied. So if you have a multiplication, that's my multiplication symbol. Those two values, whatever, you just fill in blanks with numbers, they're called factors. And then the answer is called a product. And then the product ends up being the shaded region. So you have two factors. These are factors. Now, the way that I usually do this is I would say the first factor tells you how many sets of the second factor there are. So if we go back to something a little bit more familiar, like let's say 3 times 5, like this. 3 times 5 tells you that you have 3 sets of 5. Now that means that you'd have 3 5s, 1, 2, 3, and you'd end up adding them all together. 1, 2, 3 5s added together, and then for both answers, which we hopefully know from our multiplication facts, would be 15. That means for what we're doing on this one, you're going to have the decimal. The first factor, you're going to shade that in. So this would be one full, I guess, a whole. And then the second one is what we're going to shade horizontally. And then the intersection is your final product answer on that. So we got to use a 10 by 10 grid to multiply decimals. We'll shade the first number vertically, then shade the second number horizontally. Use this to find the product. All right, so there's our grid. So our first factor here is 0.4. Okay, so like we said, we're going to shade this first one vertically. That's what it says right here. Shade the first one vertically, okay? So 0.4, that is the same as 4/10. So I need 4 of the tenths. See if we can make this work. 1, 2, 3, 4. There it is. It's not shaded very well, but that's okay. All right, then the second factor is 6/10. So we need 6 of these. 1, 2, 3, 4, 5, 6. And then we shade this in. Now, if that purple had come out better, we would see a cross shading in this. We're going to make this green area. This one right here. In fact, let's a little bit better. This one, okay? So the intersection is the actual product. All we got to do is figure out how many, well, let's see, it's not going to be in tenths, it's going to be in hundredths. So how many hundredths is that? It's a 6 by 4 rectangle, and 6 times 4 is 24. So that's 24 hundredths. You could count the boxes if you'd like, but I'm too lazy to do that. So if you want to, you can do it. I'm just not going to do it. 24 hundredths. Okay, so use a grid for this one. Shade the first number vertically, then shade the second number horizontally. Use this to find the product. Try this one out. I know it's different, but try it out. Okay, so I duplicated it so we can have 3, and as it turns out, we need 3 full rectangles right here, okay? So there's one, and yeah, I know my shading isn't always great, even though I'm using technology, but I'm doing my best. 1, 2, 3, okay? So you could say that's shaded vertically if you'd like, so 3 holes right there has been shaded vertically. Now, it says the second one has to be shaded horizontally. That's going to be our 0.5. So our horizontal shading. Okay. This may sound kind of weird, but it's not just, let's see, 1, 2, 3, 4, 5. It's not going to be just this part right here. Okay. Now again, this kind of goes back to what I was saying before. The first number tells you how many sets of the second one there are. So this is only one set of 0.5 or 5/10. So we need not just that one, but we need 3 total of them. Now again, the part of the problem here is that we have an intersection, but on 3 separate rectangles like this. And kind of what I would do, since we're looking for the intersection, I would take this intersection right here and just kind of move it over here, just so I can see everything in line. Then I can see that our final answer has a full rectangle here and then another half. So, I mean, you could have counted from the beginning, but that's 1 full and then a half, or 1.5 or 1 5/10, however you want to look at that. But that's our answer. So multiplying decimals, here's what we're going to do, is we're going to look at the 2 numbers that are being multiplied, the 2 factors. And we're going to see how many decimal places there are in the problem, meaning not just in one factor, but both factors. Then what we do is we multiply the numbers as though there were no decimals at all. So like 1.5, we're going to look at 15, knowing that there's 1 decimal place with it, okay? Now we need to keep track of those, which is our first step, because after we do the multiplication, then we have to reapply the decimal places in the end. And then, of course, we'll check our work as best we can. So, yeah, basic operation rules apply when operating with negatives, which we will have to do. So be aware of that. Okay, so the negative rules. So let's look at some examples right here. We're not going to do the problem. We're not actually going to do the operation. All we want to do is know if this answer will be a positive or a negative. So, yep, so that first one, we're going to take the base, 5.2, and it'll be multiplied, well, negative 5.2. This is what it would look like. Now, again, we don't really care what the answer is. We just want to know what type of answer we have. And yes, a negative and a negative make an answer that is a positive. Okay, now this next one, a lot of students confuse this with negative 3.7, and then they would say, well, it's multiplied by negative 3.7, but this is not true. This is not true because in that original problem, the negative is not in a set of parentheses, so there's only one negative. One negative is going to make that a negative answer. I'll use some technology, make that easier. Negative. So this next one, I would ask, of course, is the answer going to be positive or negative? But my real question is how many negatives are being multiplied on this? So that is definitely true. We got a negative. We're going to make that a negative 1 on the outside. Now, with that negative 1, so let's write that out. We have that negative 1. Now, in addition to that, though, we also have the negative 19.1. Now, that's in parentheses. So we not only have that 1, negative 19.1, but 2 of those. So, in fact, there's 3 negatives being multiplied. 3 is odd, and an odd number of negatives being multiplied or divided makes the answer a negative. So this next one, of course, the trick here is partially noticing that it is negative 1 there in the front, which again I'm going to write out. Okay, so this one, 1, 2, 3, 4 negatives. 4 is even, so this answer will be a positive. Yep. So another reason that I like to do this is because when I do the work on these, the first thing I'm going to do is determine if the answer is positive or negative. After that, I completely ignore all the negatives. I don't care about them, as long as I know what my answer is, what the sign is going to be. So if we knew that these were either positive or negative, then we can move on with the actual multiplication, which we will get to on these other problems. So let's multiply these, 11 and 37 hundredths and negative 3 and 18 hundredths. Now again, the first thing I would do on this is I just would want to determine if my answer will be a positive or a negative. This one is in the multiplication. One of the factors is positive, one is negative. Positive times a negative will result in a negative answer. Or you could say that there's an odd number of negatives, 1, and so the answer will be a negative. However you want to put that. Next up, we want to determine how many decimal places there are in the multiplication. So in the first factor, we've got 1, 2 decimal places. And then in the second factor, 1, 2. So this means that just to start this off, there are 4 decimal places. Okay, now I've written this down because we're going to need that information later once we finish the actual multiplication. But by knowing how many decimal places there are, we're going to take both numbers without any decimals. So this is going to be 1,137 times, and again, I don't need that the decimal or the negative anymore, 318. And that's what we're going to multiply. In fact, I probably should have stacked those and multiplied. So let's do that. 1,137 times 318. Now, whatever we get from this multiplication, we will reapply those 4 decimal places once we finish. Okay, so I'm going to start with the ones place value. That's an 8 times a 7. That's going to be 56. Carry the 5. 8 times the 3 will be 24 plus 5, 29. Carry the 2. 8 times 1 is 8, but add the 2 is 10. So we'll carry the 1. 8 times 1 is 8, but add 1 makes that 9. Now that was just 8 times 1,137. Now we're going to apply the 1, right, because we applied the 8 there. Try to color code that. Now, since we're in the tens place value, of course, there can't be any 1s. So, starting over, we've got 1 times 7, which is 7. Then 1 times 3, which is 3. 1 times 1 is 1. And 1 times 1 is 1. Yeah, so these red numbers were from carrying with the 8, which we've already used. So you can cover these or erase them, however you like to do it. And then now we're going to multiply the 3 in the hundredths place value. So, of course, there can't be any 1s or 10s. So 3 times 7 would be 21. Now, again, I'm kind of trying to color code these so that 2 that I've carried over is in green. So I know which one is carried. 3 times 3 is 9, but adding the 2 makes that 11, so we'll carry the 1 there. 3 times 1 is 3, but adding 1 is 4. And then 3 times 1 is 3. So all we got to do, see if I can do that a little better, at this point is just add those 3 numbers together by columns or place values. So 6 plus 0 plus 0 is 6. 9 plus 7 is 16. Plus 0 is still 16. Carry the 1. 1 plus 0 is 1. Plus 3 is 4. Plus 1 is 5. Now the thousands place value, nothing to carry, but 9 plus 1 is 10. Plus 1 is 11. Carry the 1. In the 10,000s place value, 1 plus 1 is 2. Plus 4 is 6. And then we'll just drop the 3. So that ends up being 361,566, but it is not 361,566. So don't think that this is done, because remember, we were dealing with decimals in the beginning. Remember these 4 decimal places? I now need to apply those 4. Now starting on the right, you'd have 1, 2, 3, 4 decimal places, which means the decimal needs to go here. And that also means that my final answer is not even just 36 and 1,566 ten-thousandths, but it's negative. Remember, our answer is going to be negative. So we have negative 36 and 1,566 ten-thousandths. And that is our actual final answer. So I broke this up into parts, right? The first thing that I figured out is my answer is positive or negative, then how many decimal places there are. Then I multiply without decimals, just like old-fashioned multiplication, and then we apply the original decimal places to the answer, and with the sign, we have our final answer. If you know how to multiply it, like if you started with this and knew how to multiply it, it really isn't too far away from that, right? Just know if your answer is positive or negative, and then how many decimal places to apply in the end. All right, here's this one. It's negative 81 thousandths and negative 2 ten-thousandths. Try this one out. How do you do? Let's get started then. Now for me, the first thing I would want to know is my answer going to be positive or negative? Yep, 2 negatives makes a positive, or there's an even number of negatives. So So the answer is a positive. Now I'm going to put the positive sign, although you wouldn't want to put that on the assignment. If you put it on an exam or test it, it's not a problem. Next, we'll determine how many decimal places there are total. So there's 1, 2, 3 in the first factor, and then 4, 5, 6, 7 total in the problem 4 in the second factor. So 3 and 4, 7 factors, or not 7 factors, but 7 decimal places. So there's 7 decimal places in the problem. Now we're going to need this information, but not until the very end. So now that we know that, once again, ignoring all decimals and signs, we're going to make this now 81 times 2. So we got rid of all the decimals and we got rid of all the negatives, and we don't really care. So 81 times 2, let's see how that turns out. 81 times 2, we should be able to do this. 1 times 2 is 2, 2 times 8 is 16, boom. Now again, the answer is not 162 because there should be 7 decimal places. So we're going to write this 162, which I probably should have given myself more space. Let's move it over here because I need 7 decimal places, right? That's what we found out from the beginning. So 1, 2, 3, always starting from the right. There's 3. Now we're going to have some empty place values. We'll fill those in. 4, 5, 6, 7, and that's where the decimal place should be. So I'm going to plant that 0 right there, just expecting it. But all of my empty place values that I have underlined need to be zeros as well. So we have those 4 right there, including the 1, 6, and 2, were 7 decimal places. And that's it. That's the final answer because we know that answer is going to be positive. I didn't line that up very well.
So it's 4.
Oh, I didn't line that up well either. All right. So positive, that's 162. I think that's 10 millionths. Let's find out. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. Boom, we got it. Okay, if one of the factors is a 10, in fact, it doesn't have to be a 10. It needs to be base 10, meaning the first number or the first few numbers may be not zeros. But as long as there's a bunch of zeros at the end of the number, furthest to the right, like 10, 100, or 1,000, again, this could be like 20 or 50, 100, or 67,000, something like that, whatever. Okay, the zeros at the very end are going to tell you how many times to move a decimal to the right. Now, this is important because eventually we're going to say, well, not in this math class, but eventually they're going to say move the decimal to the left. For now, it's important that you understand that we're going to move them to the right by however many zeros there are, but they have to be on the very end of the number. So if we saw a number that was like this one, this 0 does not apply to the moving of the decimal. Only the tail end ones do. So you have to keep that in mind when you're looking at these numbers. The zeros tell you how many times to move the decimal to the right. So if the other factor were, let's just throw in an example here. If we had 1.23 times 10. Now the 10 tells you the 1 0 tells you to move the decimal to the right once. 1 0, once to the right. So I would show my work by showing it the decimal going to the right one place value, and then the final answer is 12.3. Done. That's it. That's all you got to do. Now, if the first number was a 2, then I'd multiply this by 2 or 5 or whatever. But the zeros are going to tell me how many times to move that decimal, and that ends up being part of the final product. All right, so this one, we got 7 and 587 thousandths times, that's 100,000 right there, okay? Okay, so right here, we are multiplying by 1, which is good news because I don't actually have to multiply whatever this value is by anything. All I got to do is look to move that decimal, but I got to move it how many times? Well, this shows 1, 2, 3, 4, 5. I counted that, right? 5 zeros. So since there's 5 zeros, we're going to move the decimal to the right 5 times. Okay, so I'm going to write that number down here, 7 and 587 thousandths. This will help me to prepare to move the decimal to the right 5 times. So there's 1, 2, 3, sometimes students will even put arrows, whatever. 4, 5. Now, just like we saw with the last couple problems, is if I have empty place values, I just fill them in with zeros. So these are going to be zeros right here. And my final answer ends up being looks like 758,700. That's it. Now, of course, we didn't have to worry about negatives. Just know that on the assignment you may have to, right? If there were two negatives, the answer is a positive. One negative would make the answer a negative. There you go. I didn't show this, but the decimal, even though I didn't show it, it's formally right there. And whether you show it or not is completely up to you. If you show it, full credit. If you don't show it like I did, still full credit. Here's the thing. Now, that to me, that's a shortcut, which we want you to know. And it makes things nice and easy. Of course, it's not as nice of a shortcut as a calculator. But what you can do is just apply the same things that we've already done, right? You could say, well, look, there's 1, 2, 3 decimal places. And then you do 7,587 times 100,000. Now, you would get, I'm going to skip the math here, but this is what you would get. You'd get 7, 5, 8, 7, 1, 2, 1, 2, 3. So that would have been 758,700,000. That's what you would have gotten from that multiplication. But then you would have had the 3 decimal places, 1, 2, 3, and then would have put the decimal there, and you still end up with the same answer, 758,700. So I took the shortcut originally, but you don't have to take the shortcut if that shortcut is not making sense, especially if it's not making sense. All right, your employer will reimburse you 7 cents per mile driven if you drive 299.73 miles on a business trip. What is your mileage reimbursement? Okay, so every one of these miles is its own 7 cents, which means that we are looking at, that's correct, it is going to be a multiplication. So this many miles, or that many sets of 7 cents. Now we'll even look into a different way to do this, or look at it, in Module 8. But that's for later. So we are multiplying these, right? Okay, so let's go back to our the old-fashioned rules that we started with. So we're going to look at these. We know the answer is going to be positive because we got 2 positives being multiplied. So how many decimal places are there? 1, 2, 3, 4. So 4 decimal places. Okay, so we are expecting 4 decimal places. So again, I'm going to look at the first factor, not as $299.73. But 29,973, and then we'll multiply it by the second factor, again, without any decimals, just 7. So when I get this multiplied together, then we will move the decimal, and that will tell us what our final answer is in mileage reimbursement. We'll be sure to label this as well. So first up, 7 times 3 is 21, carry the 2. 7 times 7 is 49, but add the 2 makes that 51, so we'll carry the 5. 7 times 9 is 63, but add the 5 is 68. Carry the 6. 7 times 9 is 63, but add the 6 is now 69. Carry the 6. 7 times 2 is 14, but add the 6 is 20. Okay, so we end up with 209,811. But once again, we must apply these 4 decimal places. So 1, starting to the right, 1, 2, 3, 4. And our answer ends up being 20.9811. Of course, this is reimbursement, mileage reimbursement in dollars. So that means that we would round to the nearest hundredth or penny, which is where the 8 is. To the right is a 1, so the 8 will remain an 8, and we end up getting $20.98 of reimbursement. I'll write that up here, $20.98. Now, here's the other thing, too, because I think on the last exam, someone did not label an answer. The number was correct, but the label was not there. And so, unfortunately, if that happens, I'm forced against my will to take credit off. So don't forget the labels, especially on word. If you ever see a word problem, just know and make sure whenever you write your answer, make sure there's a label there. So in division has 3 parts, which I think my classes go over this in the first semester, but you got a dividend, that's the first number that's in a division problem. Then it's divided by a divisor. You'll hear me use this vocabulary often. In fractions, this is the numerator, and then this is the denominator, and then the quotient is always the quotient. But the dividend tells you how much is going to be split up or distributed. And then the divisor tells you how many parts it's going to be split up into. or groups. So division is really just asking how many times will the second value, the divisor, fit into the dividend. So if it doesn't fit evenly, then there's going to be some amount that's left over, which in the past we made a remainder, but now that we're in the decimals unit, we're going to have some decimals. And that's okay too, because if we end up having decimals, then we'll just tack on zeros, as many as we need, if there are any. So, dividing decimals with a grid. So, shade the grid with the dividend, and then all you got to do is figure out how many divisors fit into that dividend. And then that is your quotient. Okay, so we don't have any numbers. This is just kind of how it's going to look. They're going to give you two values. They're going to say, fill in this number and then this one. Or they'll give you like two of these, and they'll say, this one's the dividend, this one's the divisor, and then tell us how many divisors fit into the dividend. That's your quotient, okay? So in the past, when you saw something like this, like let's say 10 divided by 2, so if these were full units, right, you'd say, well, I'm going to fill in 10 of these. There's 10. Okay, how many 2's are there? There's 1, 2, 3, 4, 5. It's the same idea, it's just now they're going to be in decimals. That's it. And that's why we also get 10 divided by 2 is 5. How many 2's fit into 10? So on this one, this is 48 hundredths divided by 12 hundredths, which is the same as asking how many 12 hundredths fit into 48 hundredths. So just like we were talking about before, the dividend is how much is going to be split up. Okay, so we're going to take that 48 hundredths. Let's see if I can do this decently. So I'm going to have 4 rows. There's 40. And then we need an extra 8 right there. That's 48 of the hundredths. Then I've got to figure out how many 12 hundredths are going to fit in here. So there's a 10 and then a 2. And then I have an 8. And then 4, that's 12 right there. That's 2. So I should label these because of the lines. There's 1 and 2. And then what have we got? There's a 6 and then another 6. There's 3 right there. I think I'm counting this all right. Well, let's see then. Oh, yep, there's an 8. And a 4. Boom. Yep. 4 total. So, how many 12 hundredths fit into 48 hundredths? 4 exactly. I was kind of expecting maybe a decimal value in there, but I guess with these modeling, it's kind of hard to do that.
In your sentence that you...
Try this one out. See how you do. Okay, so I need 3.5 of these, right? So the numerator is the dividend. Let's shade in 3.5 of these. That's 3.5 or 3 5/10. Now, we need 7, every 7 of the tenths will be what we're splitting these up into, right? So how many 7/10 are there? There's one of them. And we can do this a little differently. So, well, I don't know if I will. There's 3, 4, 5, 6, 7 right there. I know that's not the same size because we have some space in between. That's not what I'm counting. There's the 7, and then 1, 2, 3, what is that? 6, 7 right there. And then another 7, 1, 2, 3, 7. And then these 7. Okay, so it came out exact as well. There's 1, 2, 3, 4, 5. So how many of those 7/10 fit into 3 5/10? I got 5. Now, I know we haven't gone over this, we will, but as it turns out, what you can do is you can just move the decimals one place each value right here, and then you could have just done 35 divided by 7, which, as it turns out, is still 5. Same thing. Now, the other way this would look like, because we've seen this before, this is the same as 35/10 divided by 7/10. 35 divided by 7, 5. And this would be true if we had, this was in hundredths, and this was in hundredths or thousandths or whatever. Right now. So dividend divided by divisor equal quotient. So the divisor, We do not want to show the divisor with a decimal. We don't really care if the dividend is a decimal. It's okay if it is a decimal, the first number. But what we don't want is the divisors to be decimal. So what we're going to do is we're going to move the decimal to the right as many times as we need to get rid of any decimal place values. So if there were 4 decimal place values, we'd move the decimal 4 times to the right. It's just that if we do that with the divisor, we have to do it with the dividend as well. And what that is it's just like scaling a fraction. So if we looked at a fraction like this, let's say this was 0.0578, and the decimal was 6.219 like this. What we're doing by moving the decimal is we're saying this denominator, which is the divisor, we would want to multiply this by 1,000, which would then move the decimal 3 times to the right, which would then make that denominator 6,219. But as we've seen with fractions, you can't just multiply the denominator by a value and not multiply the numerator by the same value. And all we're doing then is we're moving the decimal, like I'm saying, 1, 2, 3 times, but we're doing it for both values, whatever they are. So even though the top number, or the numerator, or the dividend may end up as a decimal, it's the denominator or the divisor that we cannot have as a decimal. Once we have these moved, then we're going to write a long division problem and just do our long division from there. Moving or applying zeros to any place values that may be empty or that may need to be dropped in order for us to continue the division because we enjoy it so much. But as usual, all the basic operation rules apply when operating with negatives. So 1 negative makes the answer a negative. 2 negatives will make the answer a positive. Same with no negatives. So if both numbers are positive, the answer will be a positive. That's probably not very clear, so let's look at this example right here. All right, so once again, I would look at this, and I would just want to know if my answer is going to be positive or negative. So I have a negative, I have a positive divided by a negative. There's 1 negative, 1 is odd, so my answer will be a negative. Or you could say a positive and a negative makes a negative. Doesn't matter. So there's my negative sign for my answer. Okay, now I'm going to look at the 2 numbers. In fact, I'm going to look at the division completely, but now without the negative. And now that I have that, I don't want the decimal either for just the divisor here. So the 2.1, I'm going to move that decimal once to the right to make that 21. But if I do it for that divisor, I've got to also do it for the dividend. So now that's going to be, instead of 23 and 31/100ths, it's now 233 and 1/10. Now none of that is going to affect the division symbol, right? It's not like we've reciprocated a value and then changed it to multiplication like we would with fractions. Not at all. We're just going to do this with straight division. But by division, we mean long division. Okay, so this is going to be 233 and 1/10 divided by 21. All right, now I'm not very good with my multiples of 21, so I'm going to make a multiples of 21 list here on the left. Okay, so I've got my first 5 multiples there, just so I can refer back to them. Let's make that visible. Okay, so my division, 21 will not go into 2. I like to put a little 0 there just so I know that that place value has been taken care of. But now, instead of looking at this as a 2, I look at it as 23. How many 21s are in 23? 1. Boom. So that was only the first multiple. That's not bad. 1 times 21 is 21. We used them up. So out of the 23, we have 2 left over because we used up 21 of them. 2 is too small to divide with 21, so we're going to have to drop the next place value, which is a 3. Okay, so 21 goes into 23 again once. 1 times 21 is 21. We already know when we subtract that, we'd have 2 left over. Oh, okay, so this is going to work out pretty good because we'll drop the next place value, which is 1. 21 goes into 21 exactly once. Now the decimal, with long division like this, the decimals here, it needs to line up with into our quotient as well. So there we go. Okay, so it's just lined up vertically like this. So our final, or the quotient of that, 233.1 divided by 21, would have been the same quotient here. It is 11.1, but don't forget the negative is part of the answer there. So by moving these two decimals, there's no need to like move it back. Some students get that confused. They're like, I got to move that decimal back. You don't have to move it back. Because what we did is we scaled the two numbers, which means we just changed the way it looks, but we did not actually change any values. So negative 11.1, it's done. That means I went way too far in my table here, but that's okay. So divide these, same idea, right? So it's just the second number. We got to make this not a decimal. I don't really care how many decimals are in this one. The first number, the dividend. So that 0.1 or 1/10, we just need to move that decimal to the right once, and that would make that a 1. Now, that being a 1 is crucial because we know anything divided by 1 is going to be itself. Oh, I skipped a little bit right there, didn't I? The answer to this, right, we have a negative divided by a positive, which is going to make the answer a negative. Okay. But divided by 0.1 or 1/10, of course, we made it a 1 by moving the decimal one time to the right. So I move it one time to the right for the dividend as well. Now that's going to make that negative 472 and 38 hundredths divided by 1. But again, anything divided by 1 is itself, which means our final answer, again, I didn't really need the negative there, but for our answer we do negative 472 and 38 hundredths. That is all. So I'm pointing this out because I don't want to do the long division, and I kind of hope you don't either. As long as we remember anything divided by 1 is itself, this is pretty much done. That is done. It's done. All right, try this one out. Now that's division, right? The fraction bar is a division sign. Try this one out, see how you do. Well, let's get to it then. All right, that 38, again, the sign, I should start with the sign. Two negatives divided or multiplied, for that matter, will make the answer a positive. So there's my positive sign, whether you want it there or not. You don't really need it, but I got it there. Okay, so now that divisor or denominator, we would move that decimal 2 times to the right to make that 38. But if we move that 2 times to the right, we got to move it 2 times to the right with the numerator as well, which is going to make that 22 and 8/10. That's better. Divided. Okay, now we don't want to see the division like this. We want to do a long division. So we're going to do 22 and 8/10 divided by 38. Now again, even for the quotient, I would expect the decimal to be here because it needs to line up with where the decimal is from the dividend as well. So with this division then, 38 will not go into 2. It will not go into 22 either. 22 is too small. So again, we look at this number not as 22 and 8/10, but 228, which as it turns out is the 1, 2, 3, 4, 5, 6th multiple. It's exactly the 6th multiple of 38. 6 times 38 is 228. So when we subtract, nothing remaining, which is kind of what we wanted. So our answer we know is going to be positive. I'll just write it as 6/10 like this. Done. Now be aware, we didn't see any examples like this today, but of course if there was a remainder, then I would have had to have tacked on a 0 there and then dropped them until there was either no remainder or until we found a repeating pattern. Okay, so we've seen this slide already, multiplying with base 10s. So multiplying with base 10s moves the decimal to the right, however many zeros there are. If we divide then, it's just going to move the decimals to the left. So I said we may not see this in this class. Here we are. So if you divide by 10, so if the divisor, that's the second number, is a 10, you would move the decimal of the dividend to the left once. Or if it's 100, there's 2 zeros, you move it to the left twice. If there's 3 zeros, you move it to the left 3 times. Division will move the decimal to the left however many zeros there are. Now again, this is kind of like a shortcut rule. So if you want to just stick with the old-fashioned division stuff, do it, because you can. So on this one, again, this is it's the same numbers we've seen before. So that's 7 and 587 thousandths divided by 100,000. So we're going to look at the zeros from the dividend. 1, 2, 3, 4, 5 zeros. So 5 zeros in my dividend, and this is division now, is going to move the decimal to the left 5 place values for the dividend. Yeah, the divisor has 5 zeros. The dividend is going to move the decimal to the left 5 times. Now, just like before, if we end up with any empty place values, then we'll fill those in with zeros. So I'm going to rewrite this number, 7 and 587 thousandths. So I'm going to move that decimal to the left 5 place values. So there's 1, 2, 3, 4, and 5. So this is where my decimal ends. And then we have 4 place values that are empty. So we're going to have to fill those in with zeros. So my final answer, I'll start with that 0 there and to the left of the decimal, 0 and 7,587. Let's see what place value that is. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths, 100 millions. So 7,587 hundred millionths is our final answer there.
We don't have to put that 0 at the end, do we?
So here's the thing with the 0 in the front. If you don't show the 0 there, just be careful, because in the past, students have shown a decimal place like this one right here. Now, you can't really see that very well, but it's showing on my iPad. And if I can't see that decimal, I don't think that you meant to put a decimal there. So if you're not going to put the 0, well, even if you do put the 0, I should say, just make sure you emphasize that decimal so that I can see it. Because if I can't see it, then I don't know where you meant to put it. So emphasize your decimals if you're going to put them in. Well, since this is a decimals unit, of course you should put them in. A case of 6 items costs $10.74 at Costco. Now, you got to be careful with this, because some students read a problem like this and they're just like, oh, six items and each costs $10.74. That's not what it's saying.
So
It's an item with 6. It's a case of 6 items that is $10.74. We want to find the cost of each item. So we are dividing. Now, you got to be careful with that as well, because some students, they're just going to do this in order. They got the 6 first, and then they got the $10.74 second, and they say, I'm going to divide these. No, that is not what you're dividing, because you're dividing the $10.74 up with 6 items. So you'd start with this $10.74 and divide it amongst 6 items. It's almost like, if you had this money, you were going to divide it with people evenly. So this is our division, and there's no need to move the decimal because our divisor doesn't have a decimal. So we're gonna write this out. We got 10 and 74 hundredths, or $10.74 divided by 6. And again, my decimals should align here. So 6 will not go into 1, but it will go into 10 once. 1 times 6 is 6. We used up 6 of the 10, so we got the 4 left. We'll drop the 7. 6 goes into 47. 7 times 6 is 42. So we used up those, and we have 5 left over. We'll drop the 4. All right, well, 6. I guess that's 9, isn't it? Okay, just had to make sure. 9 times 6 is 54. Nothing remaining, which is kind of what we wanted. So each item then would be, again, if you write this in, is 1.79. The math is correct. Everything's good, but you miss a point because you forgot the label. Make sure not to forget your labels. $1.79. Done. Okay, so we did a lot of multiplication. We did a lot of division with decimals. Hopefully we feel pretty good about it.